Hey guys, welcome to 1.1. We are going to talk about water and the properties of water and why water is essential to life. The second thing we're going to talk about is carbon and the properties of carbon and why carbon molecules form the foundation of the biomolecules. Let's go.
All right, before we can get into cell components and cell structure and function, we need to know what builds up those cell components. What are the elements involved, the properties of water, and how carbon works. So let's start off with the elements of life and the composition of living matter. 96% of all living matter is made up of 4 elements, with oxygen being the most abundant. Along with these 4 elements, we have another 3.7 to 4% made up of phosphorus, sulfur, calcium, and sodium. The key elements in an organism are oxygen, carbon, hydrogen, nitrogen, phosphorus, and sulfur. They play a key role in building the biomolecules that make up all the cellular components. So we refer to these elements as our Schnapps elements. This is just a little trick to remember the most important elements in living matter, because these are found in the carbohydrates, lipids, proteins, and nucleic acids that are required for cellular structure and function. Another set of elements that are required for cells to function properly are the trace elements. Now, trace elements are kind of unique. They are found only in very small amounts, only less than 100% of the mass of the organism, but that does not mean they are not important. Just because they're found in a very, very small amount does not mean that they are not an important element. Just the opposite. They are required for proper physiological function. So without these elements, certain biochemical processes would not happen. So for instance, let's take iron. Iron ions are associated with the hemoglobin found in red blood cells. It is these iron ions that oxygen binds to so that red blood cells can deliver the oxygen to all your tissues. So without the iron, oxygen would have nothing to bind to. And if that happens, your cells and tissues would not get the oxygen that they need in order to function properly. So even though iron is not a very big part of an organism's mass, it is critical for that function. Iodine in humans as well is important for proper thyroid function. However, some trace elements can be harmful, especially if they're found in large amounts. One example of this are heavy metals. One kind of soil pollution is heavy metals in the soil. With various processes, nuclear wastes, things like that, there are lots of heavy metals found in soils. There are heavily polluted soils. And so some organisms cannot process these metals, and so they can't grow in these highly polluted areas. Some organisms have adapted processes to help mitigate and uptake these harmful soils. Sunflowers are just one kind of plants that can do this. Sunflowers are one kind of plant that are able to uptake these metals and process them and clean the soil. We call these phytoremediators. Sunflowers are not the only organisms that can do this, but it's not uncommon to see sunflowers near nuclear power plants to help mitigate possible soil pollution. So let's move on to properties of water. 3/4 of the earth is surrounded by water. The cell is 70 to 95% water. Life evolved 3 billion years ago in a water-based environment. Life is not possible without water. So let's look into some reasons why water has such a unique set of properties and why life is not possible, why life could not survive without water. It all starts with the electronegativity difference between hydrogen and oxygen. Remember, electronegativity is the attractive force that an atom has for electrons in a covalent bond. Oxygen has a higher electronegativity than hydrogen, and the difference between their electric negativities leads to the formation of a polar covalent bond. Polar covalent bonds cause a partial positive and negative charge on the atoms in that bond. In this case, oxygen is going to have a partial negative charge, and hydrogen will have a partial positive charge. So electrons are still being shared, they're just not being shared equally. Oxygen is pulling on those electrons more so than hydrogen. And so because of this, and because of the two-low pair of electrons that oxygen has, water is going to form a bent molecule with these partial charges. So with these polar covalent bonds, and because of this polarity of the water molecule, this leads to water being able to form hydrogen bonds. Hydrogen bonds are critical to the properties of water.
I want to drive home a point about the hydrogen bonds that hold water molecules together. Water is a polar molecule. There is a positive end of the hydrogen, negative ends on the oxygen. Two water molecules are going to be attracted to each other. The positive end of the hydrogen attracted to the negative end of the oxygen. Even though the name is hydrogen bond, it is not a true bond. It is an intermolecular force. There are no electrons being shared and no electrons being transferred. These hydrogen bonds are what makes life possible and gives water all its unique properties that we're going to talk about.
In the next presentation, we will continue with our discussion on hydrogen bonds.